Okay, I think we may start. Ines, are you ready?
Yes, I am.
Okay, well, good morning, everyone, once again, and welcome to the Blended Mobility. We will talk today about the second cycle. Okay, so just to remember what we have done until now. So we have started everything talking about the innovative education in this digital era. Then we were talking about teaching computation in the first cycle, then also on the third cycle, where as you remember, we were talking about the Python language and Python course, and how could you um, create a Python course based on the Cisco Network Academy platform. And now we'll finish all this series, but with this topic, okay, the second cycle. When we're talking about the second cycle, we are talking about students that are between 10 and 12 years old, and that's precisely what we will be focused on today. So just to remember what we are doing in this project, okay, so in this Computer Science for All Erasmus project, we have been talking about how should we promote adult education. Okay, so we are mainly creating contents that should allow adults, okay, trained adults, to become a teacher of computing science that with contents that are applied to the mandatory schools. Okay, of course, on this project in particular, we have been talking only about the first, second, and third cycles. Okay, so we are talking about students between 6 and 15 years old, and the idea is to think and also to create all these materials that could allow all these students to be trained and to know about computer science. And of course, that when we are talking now about teaching students in this era, we combine several things. Okay, on the first place, of course, we are talking about formal education. Okay, the one that we get in school, but nowadays it's also very common to aggregate also non-formal education, informal education, in order to put all these students thinking and acting as youngsters, but prepared to this digital era that we are dealing with. So today we'll be focused also on how to work with a programming language and how should we work with these concepts in order to solve problems. Okay, so if a traditional way, as we all know, we typically start all these things by with programming. Okay, we choose a language, we start with a programming language, and that's it. Okay, Python language is a very popular language. Okay, very familiar to a large group of students, and also a large group of adults. But in fact, what we are doing in terms of the preparation of all these students to go deep into the programming language or a programming environment is to start from the beginning. Okay, we start by playing with the basic concepts um, that explore in somehow the fundamental mathematical concepts around the functions, and so we explore what we call the functional paradigm, and that's precisely what we will do today. So we'll go with you in a journey in which we will, of course, remember some of the concepts that we have explored in the previous sessions, but we'll go now more deeper into how programming language are used to instruct computers. So the building blocks that we'll explore on this session will be the functions, so the concept of functions, and at the same time, we'll combine functions in order to solve small problems that we will explore today. So in terms of topics and parts, we'll start with part one. So we'll go again into lists. So as you know and as you remember, lists are one of the most important data structures that we deal with when we are trying to do something with a programming language. So we'll start with numerical lists. So here we will mainly focus on remembering things that we have done in the previous sessions, but just for you to remember and also to play a little bit with these concepts in order for you to become familiar with all this. Then we'll extend all these notions to characters and strings. Then we'll start working and playing with higher order functions. So we are talking about functions that takes as arguments and other functions, and so the power increased a lot when we are talking about these kind of functions. Then we'll talk about dictionaries, and so in a more general sense, we'll be talking about pairing lists. Okay, so to start with elements that can be combined together, and then when we combine elements from two lists, we are talking about a very powerful concept that is related with this notion of pairing lists. And then we'll talk also about graphs, and then we'll finish with a very interesting problem related with collapse sequences. And if everything goes well, you will finish this session by writing a very small program that will allow you to solve a specific program related with these collapse sequences. Just another thing is that at the end, we'll also share with you a small questionnaire that we will ask you to fill and to submit at the end of the session. And we'll also share with you in a few minutes a link for a Jupyter Lab environment that you can also use and play some of the things that we'll share with you today here. So at the same time that you are attending this session, you can also, using your computer and the browser, you can use that link, and that will open an entire Jupyter Lab environment that will allow you to play a little bit with the concepts that we will explore on this session. Okay, please feel free to put your questions during the session. Okay, most part of it will be led by Ines. So just to remember, my name is Luis. I have with me Ines, and so we'll guide you through this session. I hope that you enjoy. This will be the first part, so in the morning. Okay, so we intend to finish this first part of the session in the next 1.5 hours. Then we'll start another one in the afternoon, and we'll have more, approximately 2.5 hours, 3 hours at most. And then, of course, we'll also share with you at the end of the session another link for a binder, the Jupyter Lab environment, so binder, that will allow you not only to play with the concepts that we'll show you in a few minutes, but also with all the things that will be explored and discussed during this session. Okay. So now we will jump to numeric lists. So Inez, do you want to? I will stop sharing my screen and I will allow you to share yours. Yes.
Yeah. Okay. Can everybody see my screen? Yeah.
Yep.
Okay.
Everything is okay.
So we will just remind you of numeric lists and some functions on lists. But if it is the first time with us, then this will be new for you. But it's quite simple, so just pay attention and you'll understand, I think. Okay. So when students are 10, 11, 12 years old, they start writing their first computer programs. I mean, they start writing computer programs earlier, around like 8 years old, but when they're 10, they start writing more programs and a little more complex. And we start using a programming language called Haskell. Okay, so it's a bit of an academic programming language. It's not very popular, but it's very similar to mathematical writing, so it's quite intuitive for students. And we do so by using a web-based interactive development environment called Jupyter Lab. So we don't use like text editor or anything like that. It's a platform that's more intuitive and where you can combine code cells with text cells, and so it's very versatile. All right. Now, as Luis said, lists are one of the most important data structures, and they allow us to represent elements in an orderly manner. And they're quite everywhere. So, for instance, a binary code is a list of zeros and ones, a word is simply a list of letters, a queue is a list of people, and so on and so forth. I think you can come up with several examples that can be modeled by lists. And the question is, how do we represent a list on a computer? Because a computer must know that we are dealing with a specific data structure called a list. So there are specific symbols that we need to write in order for him to know. So suppose you have a numeric sequence, which is 1, 1, 2, 3, 5, 8. If we want to represent it on a computer, we should start writing the list using these parentheses on the left. I don't really know how it is called, so I'm just going to say parentheses, and then we need to separate every element, each element by a comma, and then we must finish writing the list with another parenthesis. Okay, so we just want you to practice this a little, and I would please ask Luis to put this link in the chat, and I will ask you to click on the link, and let's start playing with the computer. Okay, so I'm just going to stop presenting, and
Yes, so the link is already available in the chat, so
oh,
you
square
can...
brackets, thank you. I wasn't sure.
Okay, so you
I'm
can
going
use
to.
that link, okay, and the link will open, as I said before, will open a Jupyter Lab environment, okay, with 3 links for the 3 topics that we'll discuss in the next few minutes.
Yeah, so I think you're seeing my screen, and if you click the link that Luis put in the chat, you should see something like this. So now we are going to click here where it says Part 1 Numeric Lists. and another window will open up. Okay? Is everybody following? I hope so.
Yeah.
So the first thing we're gonna do, and it's very important that you do this, otherwise nothing will work. You need to put the cursor in this first cell and click the play button up here, okay? So we are going to run this cell. And once you run the cell, you should see this star or a number, okay? You should see something, meaning that we have run the cell. You can also click the cell and press Shift and Enter at the same time, okay? It will also run. And once you've done this, then you're good to go. Now, let's see a first example of this, how to write a list on the computer. Very simple. I don't know if you've heard about the Fibonacci sequence, but it's a very famous sequence in mathematics. And it is a sequence of numbers such that the first term is 1, the second term is 1, and then each subsequent number is the sum of the two preceding numbers. So we have 1, 1, and then the next number is 2 because 2 is equal to 1 plus 1. And then we have 3 because 3 is equal to 1 plus 2. And then we have 5 because 5 is 2 plus 3. And then 8 because 8 is 3 plus 5, and so on and so forth. So we want to write the list of the first 8 numbers in this sequence. So what do we have to do? First, we write this right, oh, what's it called? I forgot.
Square
I'm just going
brackets.
to say,
Square
yeah,
brackets.
the left square bracket. So we
Left square
write the
bracket.
left square bracket, and now we start writing the numbers. So we already have the first 6 up here. So 1, comma, 1, comma, 2, comma, 3, comma, 5, comma, 8. And now we need 2 more because we want the first 8. So 5 plus 8 is 13. Therefore, the next number is going to be 13. And then 8 plus 13 is 21. And we already have 8 numbers, so we write the
Right square bracket.
right square bracket. My brain is not functioning very well today. And now we can run this cell just because, nothing spectacular will happen. So when we run this cell, the computer will return what we have just written. So it will return the list we have just written. And it's a way of saying, okay, you wrote that correctly. That's fine. I understood it. It's a list with these numbers, okay? So all is good. Suppose that I forgot to write the last bracket. What would happen? Well, when I run this cell without the last bracket, I will get a parse error message, okay? And it says possibly incorrect indentation or mismatched brackets. So in this case, the brackets aren't matched because I have a bracket in the beginning opening up the list, but I don't have this bracket in the end. Okay, so I really need to write a list in this way for the computer to understand. However, it's kind of not relevant the number of spaces that I put between the comments. The computer really doesn't care. So even if I write the list in this very weird fashion, I'm going to run it and everything is going to be fine, okay? So the spaces are not relevant, but we must use commas to separate the elements, and we need to use left and right square brackets to write the list. All right, so I'm just going to share the PowerPoint. No, actually, I'm not going to share the PowerPoint. I'll keep here because it's easier for me to explain. Just a second. Where was I? I think I was here. Yeah, okay. Now, suppose we want to compute the sum of all these 8 numbers in the list. there is a function called sum that allows us to do just that, okay? So what do? Well, we first write the object that we want to transform. In this case, we want to compute the sum of the numbers in this list, all right? And then we write a little arrow, okay? And then the name of the function that we want to apply. Now, let me just clarify something in case you don't really know what a function is and you have no idea what I'm talking about. So, you see, sorry. Can you see my screen? Moving?
Yep.
It's
Yes.
moving? Yeah?
Yeah,
Okay.
it's moving.
So what is a function? Well, first, we use function or transformation as synonyms, and it's very simple. A function is simply a correspondence that assigns a unique output to a given input based on a specified relationship between the two. So look at this picture. We have two sets, x and y. The set x has some polygons, and the set y has some colors. And what is the correspondence here? We are assigning each polygon its color, okay? So the triangle is red, the rectangle is yellow, the hexagon is green, and the square is red. And we represent this correspondence by an arrow, okay? And in functional programming, functions are really very important because they can be composed and manipulated in powerful ways to solve complex problems. So it's very important that we understand what a function is and what functions we have available and can play with to start writing more complex programs. Now, when dealing with numeric lists, there are very useful functions, and these functions take as input a numeric list and return a number. Well, more precisely, the function sum returns the sum of all numbers in the list. The function maximum returns the greatest element in the list, and the function length returns the number of elements in the list. We are going to see examples of each of these functions, don't worry. Now, when we are teaching this to kids, we like to use the arrow language. So this diagram above, we have list of numbers on the left, meaning that this is our input. So we are going to take as input a list of numbers. Then we have an arrow with the name sum above, meaning that we are going to apply the function sum to that list of numbers. And then on the right, we are saying that the output will be a number because the sum of a list of numbers gives a number. Now, down, we have a robot called Sum. When the kids are smaller, they really enjoy these little robots. And each robot represents a function. So here, the Sum robot takes a list as input in his right arm, and then his left arm gives the sum of all the numbers in the list. Okay, so it's very important that we understand what we are transforming, what is the type of the thing that we are transforming, and what is the type of the output. Okay, now let's move on to some examples. All right, so as I said, we first want to sum all these 8 numbers in the list. So we just have to run this cell. We have the list on the left, then this symbol resembles an arrow. Okay, this kind of looks like an arrow if you believe that it does. And then on the right, we have the function or the transformation. I'm going to run the cell, and the result is going to be 54. Okay, so the sum of all the numbers in this list is 54, as we had written here. Okay, so now let's recall these functions on list. We have sum that returns the sum of all numbers in the list, maximum that returns the greatest element in the list, and length that returns the number of elements in the list. So let's move on to example number 2. Suppose that Charles went to a restaurant and ordered a hamburger that cost 5 euros, a large soda that cost 2 euros, a small coffee for 1 euro, and a chocolate brownie for 2 euros. We want to know how much Charles paid. Now, we don't want to write the answer. I know that the answer is obvious, but we want to write a computer program or expression that will yield the answer. We don't want to compute the answer by hand, you know? So what can we do? First, we model this problem by a list. We represent the data using a numeric list. So the list is 5212 because these numbers correspond to the prices of the products that Charles bought, okay? So starting with this list, how do we know what function, which one of these functions should we apply to compute how much he paid? You can write your answers in the chat, please.
And don't forget that you can also test in your environment as well. Okay, so we can play with your environment by
So we
solve
already
these
have
problems. Yeah,
the right
correct.
answer. So it's sum, okay? So in front of the arrow, we write sum, and now we press play. And Chana, we computed the sum. Oops, we computed the sum of this list. Now we want to know how many products he bought. How many? So the number of products he bought. Which of these functions should we apply to our list 5212 in order to obtain the number of products that Charles bought? Sum, maximum, or length? Please write your answer in the chat. So I want something like this. Exactly, it's length.
Right.
So I start with a list, I put this little arrow, and now I write length, okay? Now if I run this cell, you get 4. And if you do that in your computer, you should get 4 too. Finally, I want to know what was the price of the most expensive item. Which of these functions should I use? So I want to know what was the most expensive item, so with the highest price. All right, we have a correct answer, so it's maximum. I'm just going to apply function maximum here. Oops. All right. And we get 5. So 5 was indeed the most, the highest price of the hamburger. Now, so far we have dealt with functions that take as input a list and output a number. But there are other types of functions. I hate moving from one window to another. Okay. So there are other types of functions. Let's see some more. So we have functions now that transforms list into lists. Okay. So far we've seen functions that transform lists into numbers. Now we will deal with functions that transform lists into lists. And again, we will look at 3 functions. Function sort takes as input a list and returns a new list with the elements in ascending order. So first the smallest element, then the second smallest, blah, 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 and the last element will be the largest. Then we have function reverse, which returns a list with the elements in reverse order. So the last element will be the first, the second last will be the second element, so on and so forth. And finally, we have function nub, which returns a new list with all duplicates removed. So if the original list has several equal numbers, we will just consider one of those. Okay, so we will delete repetitions. For instance, how does our arrow diagram look like for the function sort? So the function sort takes as input a list and outputs the list in ascending order. For example, if the input is the list 423122, the output will be the list 122234. So the elements are in increasing order. Okay? Let's take a look at some examples then. All right, so sort, reverse, and nub. This is what we're going to deal with. You see, in this example, you may be thinking, oh, this was so easy. I would be faster than the computer returning the answers because we can just calculate it with using our head. It's very easy. But now we are going to work with larger lists, okay? Lists that have really a big number of elements. So suppose that I want to sort the numbers of this list in ascending order. I bet you would have some trouble if you had to do it using only your head, right? So computers are useful when we want to perform transformations with a large number of data, okay? With lists that have many elements. Now, what should we write if we want to sort the numbers in this list? Which function should we apply? Exactly. It is the sort function. So I write the arrow, and then I write the function, sort, and I press play, and the list is in increasing order. 55, 88, 113, 125. So the first number is the smallest and the last number is the largest. Now I want to reverse the order of the elements in this list. Which of these functions should I apply? Exactly, it's reverse. I want to reverse the order of the elements, so I apply reverse. And when I press play, the elements will appear in reverse order. So the last element, 1, 1, 2, 4, 5, will appear first. The second last, 1, 1, 3, will appear second, and so on and so forth. So we have reversed the order of the elements in the list. Last but not least, we want to remove all duplicates from the list below. All right. So we want to eliminate numbers that are the same. Which of the functions here should I use? Sort, reverse, or nub? Nub. Very well. Cesar is on fire today. So we apply function nub. I'm going to run this cell. See? And so we can really notice, but this it has eliminated all the repeating numbers. So to understand nub better, because you may not really understand, how do I create a new cell, Luis? Can I do that?
Yeah, of course. It's just, you can just link on the plus. Sorry. If you go
There's
to
no plus.
oh yeah, you can. It is no plus. But if you can, I think with the control enter, you can, or command enter, you can do that.
No. It just executes the cell. Well, whatever. I'm going to create the cell somewhere else. Okay, so suppose that I have 1, 3, 2, 1, 2, 1, 3, 4, 2, and I apply nub. If I press play, the result will be 1, 3, 2, 4. because it only keeps one copy of each number by the order the numbers appear. So 1, as 1 already appeared in the list, no, therefore we are going to write it. 3, as 3 already appeared, no, so we're gonna write it. 2, as 2 already appeared, no, so we are going to write it. 1, is 1 already on the list? Yes, it is here, so we are not going to write it. 2 is already on the list? Yes, it's here, so we're not gonna write it. 1 is already on the list, we don't write it. 3 is already on the list, we don't write it. 4 is not on the list because so far we only have 1 through 2. So this is the first 4 that appears. Here are no 4s, so we write it on a list. And then we have 2, which already appears on the list, so we don't write it, okay? So we just keep a copy of each number by the order they appear, okay? Cool. Now,
So Inez, if you want to create a new cell, you can copy one cell and just paste it.
okay, yeah,
Okay.
thank you. Now, true power is achieved when we compose functions. So what does this mean? This means that we apply one function after another. For instance, suppose that we want to compute the sum of all the distinct numbers in the list 3, 2, 7, 1, 7, 2, 4. What should we write? How should we do this? So we want the sum of all the distinct numbers in the list. So what is the first thing that we have to do? Well, if we want only the distinct numbers, we need to remove duplicates, right? So we need to apply function nub in order to get rid of repeating numbers. And then we sum the result, right? So the output of these will be a list, will be the list without with the duplicates removed, and then we apply sum to that. Okay, so we have here a list of numbers. We apply nub, we get another list of numbers, and then we sum and we get 17, which is precisely the sum of all the distinct elements in this list. Let's do this step by step. So I'm going to copy cell and then I'm going to paste it. So if I apply just nub, I get the list with the duplicates removed. Okay. And now if I take this list here and I apply sum, I get 17. Okay. And I can do it all at the same time by writing arrow after arrow, function after function, It's like a robot holds the hand of another robot and passes its output to the other robot, which will take it as input. Okay? Makes sense? Is everybody following? I hope so.
Yeah.
Okay, so now let's move on to the next example. Suppose we want to know how many distinct elements this list has. We need to combine two functions in order to solve this problem. What function should we apply first, and what function should we apply second? So we want to know the number of distinct elements. And we have all these functions here. So we have sort, reverse, snub, and we also have some maximum and length. So what functions should we apply in order to compute the number of distinct elements in this list? Exactly. So first we apply nub to get rid of duplicates, and then we apply length to count the number of elements in that list. Press play, and the answer is 195. Okay, good. And what if we want to sum all the distinct elements? Which functions should we apply? Exactly, so first nub, get rid of duplicates, and then we are going to sum them. Okay, and this is the sum. If we were to do it by hand, we would take like 10 years or something and make several mistakes in the way. And now, this is a bit more interesting. We want to sort the elements in descending order. So function sort puts the elements in ascending order, in increasing order. And now we want them in descending order. Which functions should we apply? Well, the first one is not nub, but I think you had the right idea. So what's the first function? We want to write them in descending order. Yeah, exactly. So the first function is reverse. No, not reverse. Sorry, then the first function is not in reverse. It's the opposite, okay? So first it is sort, okay? So first we write the elements in ascending order, starting with the smallest and ending with the largest, and then we apply reverse, okay? Because if you reverse a list in ascending order, you get a list in descending order, right? Let's see what happens with a smaller list. Say I have 1, 3, 2, 2, 4, 3, 5. Okay? So if I apply sort, the elements will appear in increasing order. Now if I flip this list and write the elements in reverse order, what will happen? So I'm going to take this list, apply reverse, and I'm gonna get 5, 4, 3, 3, 2, 2, 1. Right? So I have the elements in decreasing order. So what we did was we first applied sort and then we applied reverse. Make sense?
Okay, so it's
Great.
important now to summarize everything that we have discussed and played with until now. Okay, so the question is, why are we doing things on this way? Okay, but just to remember everything that Inez has said until now. So first of all, we identify the data. We try to identify the data and we try to model the data that we'll deal with. So and that's, for example, the example with the items, the McDonald items and so on, was an example of how we can do that. Okay, so we were looking at the problem. We were trying first of all to identify the data and how to model the problem. Okay, on that case, we're modeling that problem using a list. Then the other thing that is really important is to what to do, what can we do, and what do we want to do with that data. Okay, and so here we are using functions. Okay, and the importance of using functions is that there is no side effects. Okay, so when we compare this methodology and this way of doing things, when we are trying to teach young students to on all these concepts, the importance of this is that we don't have side effects. We just have an input and then we'll have an output after the transformation. Okay. The other important thing is that then the students will be focused on try to identify and try to find similarities when we are dealing with these inputs and outputs. And so this is also important because they realize that we are transforming specific objects, and that's when we try to guide them to the identification of the type of these objects. So in some cases we have numbers, in some cases we have lists of numbers, and so on and so on. And so after dealing with those identifications of the types of these objects, then we realize that we can combine these. Okay, and so we may have an input that is transformed into an output, but then the output becomes the input of another function. And if everything goes well, and so if the types of the output of the first function is the same as the input of the second function, then everything can be combined. Okay, and so by doing this, we are in fact exploring very powerful concepts, but in a very natural way. And we, of course, we expect to be easier for students to understand the power of these combinations. Okay, and independently of using a functional paradigm like the one we are dealing with here, or if we are using an imperative paradigm, okay, these notions and concepts are explored in different ways. And again, the reason we are doing this in the beginning, guided by the functional paradigm, is just to avoid noise around the concepts that we are trying to teach to our students. Okay, we really believe that starting with the imperative program has that side effect, which is not good when we are dealing with these concepts for the first time. Okay. And so,
Yeah,
as
and
I said, so we can now open to your questions. We open the time to your questions. But sorry, Ines, you were saying something?
yeah, I just want to say that not every pair of functions can be composed. So for instance, we cannot apply maximum and then sum, because for two functions to be composed, the input of the second one must be of the same type as the output of the first one. So here, imagine that we want to apply first maximum and then sum. That doesn't make sense because the output of maximum is a number, but sum only takes list of numbers as input. So here we have different types, and these functions cannot be composed. I cannot sum a number, I can only sum a list. Okay, so I may show you what I mean by this. So suppose I do 1, 2, 1, 5, 4, whatever, and then I do maximum, and then I do sum. Okay, so I have this massive error because it doesn't make sense, you see. If I do this, I get 5, and 5 sum doesn't make sense because 5 is not a list. If it were like 5 sum with brackets, then it would be a list, okay? And the sum would obviously be 5. But this doesn't make sense. And so this doesn't make sense either. Okay? So
Just a final note on everything that both Ines and myself were saying. Okay, in the summary of all of this part of the session, is this. So another important thing when we are doing the things the way we are doing is that you are really focused on the problem you are trying to solve. You are really focused on the elements that will allow you to solve the problem. Just as an example, on this last exercise, okay, we were asking to put a list and sort the elements of the list in descending order. Okay, A good example, for instance, for you to explore your students based on what we have done is, for instance, to ask them if if we if we get list and then sort it, and after sort it, reverse it, is the same of getting the list and first reverse it and then sort it. Okay, these are very good examples and exercises that you can do with the students right after dealing with these kind of functions. Okay, so on this session, as you have seen, where we were talking about 6 functions. Okay, but then we have already lots of ingredients to do lots of exercises around these same concepts and around these same objects that we have been dealing with. Okay, and so my question to you is this. Okay, so on that last exercise, if we do the sort and we apply sort first and then reverse, the result is or not the same as if we apply the reverse first and then sort. Okay, because if we think it in a light way, okay, you can easily say that, yeah, okay, it's the same. Okay, and then this kind of exercise is very useful because nothing like to do that in the computer and to explore that in the computer and check the result afterwards. But of course, every time we do this with our students, we of course try to solve the problem intellectually, so by using only their heads, and only then we show the results and we ask them to explore the results in the computer. Okay.
Yeah, so Luis is asking if this is the same as this.
Yeah.
Does the order matter or not? Will the output be the same or not? What do you think?
Yeah. As you can see from the time that you are thinking about this problem. So this is a kind of exercise that seems easy, but it's tricky, you know?
It's not the
Yeah.
same, exactly. It's
Yeah.
not the
Yeah.
same.
Yeah.
Because here
That's
the
right.
elements will simply be in increasing order, okay? So this yields decreasing order and this increasing order,
Yeah.
because, this sort wins and it's going to just write it in increasing order, whatever happens first. And here reverse wins, okay? So they are indeed different. The order by which we apply functions is indeed important.
Yeah.
Thank you, Luis. That's very relevant.
Yeah, but these are kind of exercises because you can then put some exercises in which you have the same results if you apply these functions in opposite orders and opposite sequences and so on, so on. So just to remember you that these are very basic but powerful concepts, ones that we are dealing with. Okay.
Can we move on?
Yeah, I think so.
Okay. So now we're going to talk about characters and strings. What is this, you ask? Well, so far we have only dealt with numbers, which constitute a specific data type. But there are other data types. And we use characters to identify space character and several other symbols. So basically everything that you see on your keyboard is a character, okay? And what is a string? Well, a string is simply a list of characters, all right? For instance, this list of characters here which is HELLO space WORLD exclamation point, is the same as the string hello world. Characters use only one, how is it called, this thing? One quotation mark, and then strings
and double quotation,
use
strings are
double
double
quotation
quotation
marks. Okay. And luckily, we can apply some of the previous functions to strings. Okay, so except for the sum function, all of the previous functions can be applied to strings. So if I, for instance, if I have banana and I apply function maximum, I'm going to get the character n, because n is the greatest character if we think about the letters in alphabetic order. So if A comes first, and then B, and then C, and then D, and then N. Okay, so that is like the element with the greatest value if you think with the alphabetic order. And then if we ask what's the length of banana, well, banana is a list of characters, and it has 6 characters, BANANA. So the answer will be 6. We can also sort the characters in banana according to the alphabetic order. So it's going to be A, B, and N. We can reverse this string. We can remove duplicates using nub. And of course, we can compose these functions just like we did with numeric lists. Let's see some examples then. Now, I would like you to think for yourselves and write the answers to these exercises before watching me do it. So first we need to go to, so in the same link, click in index. We're going to go to the index, and I'm going to ask you to click here, part 2, characters and strings. Click here, and the new window will pop up. It may take some time. A lot of time.
Yeah, sometimes
Well,
it
I'm just
takes
going to
more time.
I'm going to reload this page.
Yeah, if you face this same problem, okay, and if it takes lots of time, then it's just you can just try to start the link again from the very beginning, and then everything will go well.
Well, this isn't going as expected. I'm just gonna close this.
Yeah,
And okay, so I closed the first one and everything is all right. So maybe you should just close the other tab and open just the part 2. Okay?
yeah.
Is everybody seeing this second part? Has it loaded yet? Yes, good. So please do not forget to run this cell, okay? So click on this cell and press play, otherwise nothing will work. Now here you have the names of the functions that we have dealt so far and that we can also apply to strings. And here we have some examples of characters, you see. So we write this single quotation mark, okay, and is going to accept these characters. And if I forget, is going to be upset. Just copy this cell. And then, oops, paste it. Okay, so suppose that I forgot this last quotation mark. It's not gonna like it. I'm going to get an error. So please always write everything you're supposed to write. Do not forget every symbol, any symbol. Now here we have some examples of strings. So this is a string, double quotation mark in the beginning and in the end. This is also a string. And now what happens if I run these? So this is also a string because it's a list of characters, okay? So this is just a different way of typing the string hello world. Here the characters are explicit and separated by commas, and we also have the space character here, okay? And here is just a more condensed version of writing the same thing, but they are both the same, okay? So the computer is just saying, okay, so that's the same as this. Not a big deal. Now, I will ask you to do these activities, okay? And write the answers in the chat using the knowledge that you have so far. So the longest word in the English dictionary is pneumo-ultramicroscopic silicovolcanoconiosis. How many letters does this word have? What function should we apply here? We want to know how many letters this has. Exactly, so we apply length because we want to know the number of characters in this list of characters. We apply length and we get 45. So this word has 45 letters. And if we write this word backwards, what do we get? So what function should we apply here in order to have this word written backwards? Exactly, it's reverse, okay? And it's going to write the word backwards. Very good. And if I want to order the letters alphabetically, what function do I apply? Exactly, it's sort. So first I have the A's, then the C's, then the E, then the I's, then the L's, so on and so forth. Can I read the word backwards? I may try, but I think I will fail miserably. Sizoinokonak, lovo, silicis, poxor, simart, luonomwen. That was my best attempt.
Yeah.
Okay, so D. If we eliminate repeated letters, what word do we get? What function should I apply now? Nub, very good. And you see, this word is like very big, it's huge, but if we eliminate repeated letters, we get a much smaller word, which means that it has a lot of repeated letters. In fact, how many letters does this word have? And here I want to apply, two functions. So I want to know the number of letters in this word here, which is the original one without repeated letters. So what functions should I apply? What function should I apply first and then second?
Yep.
That's right. So first I remove duplicates and then I count what I get. Okay? And it tells me 14. So this big word has 45 letters, but only 14 distinct ones. Okay? And we can confirm it. So if I count the number of letters, I get 14. So the computer is not lying to me. It's working fine. Okay, now let's explore some other functions. So, new problem. Suppose that we want to know the number of words in the sentence, I really like computers. Okay, so I want to know how many words this sentence has. How can we do that? If I write length, do I get what I want? So I'm going to replace these. No, yeah. So if I do, I really like computers, length is going to see 23. But this sentence doesn't have 23 words. It has 4 words and 23 characters. So length computes the number of characters, not the number of words. Okay? Now, if we want to compute the number of words, we need to use another function called, guess what? Words. And what does words do? Well, words takes as input a string and produces a list of strings where each element is a word of the original string. So if we apply words to I really like computers, we get a list with the words I really like computers. Okay? Easy, right? Now, with this knowledge, let's move on to activity number 2. We have this big sentence. A big black bug beat a big black bug beat a big black bear and made the big black bear bleed blood. Okay? So we want to know how many characters, meaning how many letters and spaces, this sentence has. To count the number of characters, what function should I apply? Characters, okay? So letters and spaces. A big black bug beat a big black bug beat a big black bear and made the big black bear bleed blood. Length, exactly. So I just want to know like how many characters it has. So the answer is 76. Now I want to transform this sentence into the list of words that constitute it. What should I do? I want to get a list whose elements are the words of this sentence. Yeah, exactly. We apply the function words. See? It does precisely this. Good. Now we have a list whose elements are the words of the original sentence. Very good. Finally, how many words does the sentence have? What functions? Now I need 2 functions. Okay. What function should I apply to compute the number of words? Precisely. So first we do words, and then we do length. Oops, length. Okay, so this will give us the list of words, this list here, and then we just count the number of elements. We count the number of words, and we get what we want. So 17. Conclusion. This sentence has 17 words and 76 characters, so 76 letters or spaces. Good. Now we're going to take a look at another function called unwords. So unwords does the opposite of words. So it takes a list of strings, like I really like computers, and transforms it into the sentence whose words are the elements of the original list. So if I press play here, I'm going to get I really like computers. So I have a list of words and I join them using spaces to get just a sentence, a single string. Okay, good. So let's move on to our final activity related to characters and strings. So I don't know if you're a Star Wars fan and what's written here isn't exactly true, but let's pretend it's true. So everybody knows that Yoda speaks differently, you know, and we are going to suppose that Yoda speaks backwards. He doesn't exactly speaks backwards, but pretend that he does. So this means that he reverses the order by which the words appear in the sentence. What does this mean? For instance, instead of saying, I really like computers, let's suppose that Yoda would say, computers like really I. So it starts by saying the last word, then the second last, and so on. So it's like he reads the words from right to left instead of reading them from left to right. Okay? So what happens if we apply function reverse to sentence 1? So if I apply reverse here to I really like computers, do I get sentence number 2? Yes or no? No, I'm not going to get sentence number 2. I'm going to get this string reversed. So the letters, you see, are reversed. So I start with S, R. It's like I'm reading every letter from right to left, but not the words. Okay? So what is the expression that allows us to transform sentence 1 into sentence 2 using the functions that we have seen so far? I'm going to give you a hint. We are going to need 3 functions. What are these 3 functions? Exactly, that's perfect. That's perfect. So first, we write words to get the list of words that constitute the sentence. Once we have that list of words, we are going to reverse the elements of the list. And now, after doing this, we have a list of words where the words are in reverse order. But now we need to apply unwords in order to get just a string, okay? Let's see this step by step. So if I apply just words, I get I really like computers, okay? Now I'm going to apply reverse, and I'm going to get computers like really I, but I have a list of strings and not a single string. So finally, in order for me to get a single string, I need to apply unwords to transform this into a sentence. Okay? Very well. And now, so we can apply this to every sentence. So what would the sentence "a big black bug beat a big black bear and made the big black bear bleed blood"? In Yoda's language, how would this sentence be like? So we just need to apply the same transformations, right? We apply words and then reverse and then onwards. And we get this. Blood bleed bear black big the maiden bear black big a bit bug black big a. I challenge you to read this. Okay? And that's it. Now we're
Yeah,
going
I
to take
think
a
that
break,
yeah,
but before
short
taking
break.
a break, does anybody have questions? So I'm just going to show you a diagram. You see here. Oops, okay. Yeah. Words and words are called inverse functions. So mathematically, they are mutually inverse because words takes as input a string and returns a list of strings with the words that um, constitute the original string. And then we have on words that transforms a list of strings into a string. So we have an arrow going down, another arrow going up. This means that if we apply words and then on words, we return to the same place, okay? If I have a string and I apply words and then on words, I get the original string, nothing happens. So I get the identity function. And the same happens if I have a list of strings and I apply on words and then words. Nothing happens, so I get the original list of strings because these functions are mutually inverse. So applying one after the other just gives the original input. So does anybody have any question? Luis, do you want to say something else?
No. I just want to suggest you to play a little bit with this Jupyter environment and to play with these concepts a little bit more, okay? And because it will be important for you to understand that after dealing with these building blocks, you can very quickly to solve very specific problems, very complex problems in an easy way, let's say. Okay, and so it's important for you to play a little bit with this using this Jupyter Lab environment in order for you to taste to taste exactly what we are trying to say here. Well, if there is no further question, I would suggest to take a 15 minutes break and to restart session at
11:15 maybe,
yeah 11:15 I think. Okay,
or
if every
11:20, I don't know.
everyone or
11:50,
11,
I think.
yeah 11:50, yeah. So if everybody agrees, okay,
Yeah.
so
See you
see you
soon.
at see you soon.
Oh,
Yeah.
I think we have a question.
Oh yeah.
Yeah.
So I think that let me allow you to use your camera and microphone. Yeah, please, Mocapso.
Oh, your time is 12. Yeah, we're not in the same time zone. Yeah, but so just count
Oh,
50 minutes from now. For you is 12:15.
okay. Okay.
So, see you soon.
See you soon. See you soon. Okay, here we are again. Hello, everybody. Everybody ready?
Hi, welcome
Hello.
back. Let's just wait a couple more minutes. Okay, can we restart? All right, so now we're going to talk about higher order functions. So I'm going to ask you to, so you have probably have opened this file of the second part. I'm going to ask you to close it and then come here and click in this part 3, higher order functions. And then have some patience until it loads.
Yeah, again, if you have problems when you are trying to load these sheets, please just close the browser or just the Jupyter Lab session and then restart everything from scratch by using the link that we have shared with you in the beginning of this session. It's just because these binders, if we take it takes some time in order to restart the binder, then we may face some problems.
Yeah, I reloaded mine. Okay. So, please let me know once you have already opened this file. Okay, I think we can move on. Again, please execute this first cell by clicking the play button. Now, let's look at this problem. Suppose that I have a list of words, okay? You should study math. And I want to reverse every word in the list. So I want to go to each word and reverse it. Do you think this instruction, you should study math, reverse? So if we apply the reverse function to this list of words, do we get each word reversed? What do you think will happen if we press play? Will every word appear reversed if I apply reverse to this list of strings? Is there anybody in there? Okay, yeah, exactly. So if we reverse this list, we just, we are just going to reverse the order by which the words appear. Yeah, so it's going to be math, study, should you. But we want to reverse every word, okay? Every single one of them. So we need another function, a special function, the queen of functions. So we will have to invoke a higher order function. And what is a higher order function? Well, it's basically a function that takes as input another function, okay, or several functions. And we are only going to work with the map function, but there are several higher order functions which are really very powerful. Okay, so we are going to work with the function map. Now, this transformation isn't able to do anything on its own. For example, if I take this list and I apply map, I'm going to get an error message. Okay, because map only works if I combine it with another function. On its own, it doesn't have the power to do anything. Okay?
Inez, may I just say one thing?
Yeah, sure.
Okay, so just to, because this will be now a very important part of our session. Okay, and so because we are really talking now about powerful functions, these higher order functions, but just for you also to compare with this approach, when you do things like we will do here, and how you should solve this problem if you were using an imperative language. Okay, so in an imperative language, you were looking at this and you see an array of strings, and then you were immediately um, looking at this as something that is solved by using a loop. Okay, so you go into each element of this array, and since each element of this array is a string, then you will apply functions on strings. Okay, but again, you will think about loops and not as you are seeing here. Okay, because what you are seeing here is again a list of something, so a list of objects, objects that are strings, and then you will try to apply this same concept that we saw before to this same problem. Okay, so you will see a list of strings, and then you see the objects that are strings, and you are looking now for the function that will allow you to solve the problem that you are trying to solve for each element. Okay, and this is a huge difference when we are dealing with this functional paradigm, when comparing to an imperative paradigm like the ones you can find in the most well-known language, programming language in the world. Okay. So sorry, Ines, just for
No, thank
to
you,
do
thank
this
you.
introduction,
Yeah,
just for the
thank you.
people to compare these two approaches.
Yeah, of course. So map doesn't do anything on its own, but it allows us to apply the same function to every element of a list. What do I mean by this? So if I put map reverse, I'll get this, okay? So the word you will appear backwards. The word should will appear backwards. The word study will also appear backwards. And finally, we have the reverse of the word math. So what does map do? It takes a function, in this case, the function reverse, but it can be any function, and applies it to every element in a list. Okay? So this is why it's powerful, because simultaneously it applies the same function to every element of a list. So in this, using our robot analogy, you may picture map as being a robot with several arms. In fact, with as many arms as elements in the list, and then it takes other robots, in this case reverse, and applies every other the same robot to every element of the list. Okay, so this is why map is the queen of functions, the queen of robots, because it takes other robots and applies them to every element of a list. Okay,
Yeah, and most
so
important is that the map preserves the structure. Okay, so it means that we are starting with a list and the result is a list, but the elements of the list are transformed by a function. Okay, and this is the most important characteristic of the map function. Okay, it preserves the structure that we are dealing with.
exactly. So this is a comparison. If we have a string and we reverse the string, we get a string. Okay, so if I reverse hello, I get hole, you know. Now, what does map do? Well, map is applied to a list of strings, not a string. And it can be a list of anything, but in this case, we applied map reverse to a list of strings, and the result is also a list of strings. So as Luis was saying, the structure of list is preserved. We have a list on the left, and we have a list on the right, okay? So map allows us to apply functions defined on something to lists of that something. Another example, if we apply map length to this list of strings, we get the length of each word. So we are going to get 3654. Why? Well, because you has 3 letters, should as 6 letters, study as 5 letters, and math as 4 letters. Okay? So the diagram now looks like this. So we are applying length to a string, and the output is a number. And then, oh, it says map reverse here, but it should be map length. I'm sorry, it should be map length, okay? So map length takes a list of strings and outputs a list of numbers, okay? Not map reverse, map length. Now, let's practice a little. So recall the sentence, okay? That sentence with many words. Tongue twister. We want to write an expression to transform this sentence into a numeric list with the number of letters in each word. So what should we apply? Just an observation before we move on, actually. You see, this is not the same as this. This is an error, okay? So it's not like we apply map and then we apply length. It's like map length is a function on its own, okay? So there is no arrow, no symbol between map and length, only a space, all right? It's a mistake that students sometimes make. So I want to transform this into a numeric list where each number corresponds to the number of letters in each word in this sentence. So what should I do? Okay, so we have words and then map length. Okay, and that's correct. 1, 3, 5, 3, etc., etc. So A as one word, then big as 3 words, then black as 5 words, and so on. What would happen if I were to apply? Okay, let me just copy this cell. What if I did this? What would happen? What do you think the result would be? Let's see. It's an error. Exactly, okay? Because I need to apply map to a... So length does not work on characters. It works on strings. And this is indeed a list. This is a list of characters, but I cannot apply length to a character, only to a list. Okay, so see, this length doesn't make sense. This is why we have an error, because this is a list of characters and length does not operate on characters. It operates on strings, okay? So very good. Now, how do I delete this? I don't know, and I don't care. So now we want to know the total number of letters in this sentence. What should I do? I want to count the letters only. I don't care about the spaces, okay? So length will not work on its own. I want to add one more transformation after this in order to get the total number of letters, okay? I want to take this and apply another transformation in order to get the total number of letters. What transformation should it be? Exactly. So we simply apply sum and we get 60. And that's the number of letters. You see, so with all these functions we have seen so far, we can do several things with strings. We can count the number of characters, we can count the number of words, we can count the number of letters using different approaches. So with a small number of functions, we can really do a lot when we start combining them together. Cool. Now, I want you to write an expression to reverse each word in this sentence. We want to reverse each word in this sentence, and we want the result to be a string, not a list of strings. So what functions should we apply to reverse each word? Okay, so if we apply words and then map reverse, we get a list where each word appears backwards. Okay, very well. But this is not a string, this is a list of strings. And I want the result to be a string. So what else do I have to apply in order to transform this into a single string? Yeah, and words, okay? Now I did what I wanted. Okay, very good, very well. So this is not Yoda language, and this is also not reversing the whole sentence, okay? This is reversing every word in the sentence, but keeping the order of the words, okay? So it's just as I said, we can do a lot we get different results by playing around with different ways of combining these functions. Okay, final activity. So consider this list, okay? This list, the elements of these lists are numeric lists. So it is a list of lists, you know, inception. And first I want you to write an expression to sort each numeric list in the list above in increasing order. What should we write? So, what function allows us to sort a numeric list? And then you just need to, yeah, exactly. So sort allows us to sort a numeric list. And if we want to apply to every element of the list, we use map. So map sort will do what we want. 622 will become 226. 314 will become 134. And 512 will become 125. So I did what I wanted. I sorted each numeric list on the list above. Cool. Now, what if I want to sort each numeric list in decreasing order? What should I do? Okay, so let's try that. Let's do map sort and then reverse. It's not exactly what you wanted, is it? Because these lists are still in increasing order. What we did was we reversed the order by which they appear, but they are in increasing order, and I want them to be in decreasing order. So we are almost there, but not exactly. What is missing? After I sort each list, I need to reverse them, right? So what's missing? Precisely, very well. It's map reverse, okay? That's it. Now we have each list in decreasing order, okay? So first we use map sort to put each list in increasing order. And then we want to reverse every list. So we need to use map again because we want to act over every list. Therefore, map reverse. Great. Now, last exercise. Write an expression to compute the sum of all the numbers that constitute the elements of the list above. I want to sum all these numbers. I want to know what's the result of 6 plus 2 plus 2 plus 3 plus 1 plus 4 plus 5 plus 1 plus 2. What should I write? Great. So I do map sum to compute the sum of each list, and then I just need to sum those numbers. 26. Okay, let's see this step by step. So if I do map sum, I get the sum of each individual list. So 6 plus 2 plus 2 is 10, 3 plus 1 plus 4 is 8, 5 plus 1 plus 2 is 8. And then if I, sum these, 10, 8, 8, I get 26, okay? So that's precisely it. And I guess this is the end of part 3. So,
Yeah,
if you
Ines,
have, yes,
will you allow me just to put here a short example of how powerful this language that we are using is, and the
sure,
concepts, and
yeah,
how these concepts can combine in a more advanced ways that that you can imagine. So if you go up a little bit, just go up. So for the yeah, but for the B, no, below, down, down. Yeah, on B. Yeah, okay.
yeah, yeah,
If instead of using that, you simply put map and then between parentheses, please, please, Ines, just write what I will say to you.
yeah,
Okay, between parentheses, then you'll put reverse dot sort. Okay, so if you play with it, and so you execute that cell, okay,
yeah,
you will see exactly the same thing. But just for you, this is just a small parenthesis, but just for you to see how, if we want to then to explore all these concepts in a more advanced way with older students, okay, then we can do things like this. Okay, so what we are doing now is to create a new function that is in fact the composition of reverse and sort. Okay,
yeah,
and
but it's
so again,
reverse after sort.
yeah,
Okay,
yeah,
this we should read this as after. This is
yeah,
functional composition in the traditional way, in the same way that you see in math, okay? So it's reverse after sort, which means that we apply first sort and then reverse.
yeah. But here, this small example is just for you to know and to understand that, okay, so we have map, and map takes a function, okay? And so we have now also another ways to easily create a new function based on composition of functions. And this is as an example just for you to see exactly how I can do that. So reverse after sort, or reverse dot sort, means that we are creating a new function that we are now putting this function as an argument for map. Okay, and it does exactly the same thing that we have done by putting the map sort first and then the map reverse afterwards. Okay, just a small parenthesis just for you for you to understand how powerful all these can be.
Yeah.
Okay, any questions at this stage? I don't know, Yasmin, if you have executed the first cell. It's important for you to execute the
Yeah,
first
probably
cell.
you forgot to execute the first cell.
You should go, Yasmin. You should go to the beginning of the notebook, and then you need to
Yeah,
execute the
this cell
first cell.
here.
Yeah.
Yeah, you should execute it. Never forget to execute this first cell.
And then after doing that, you can jump directly to the cell you are trying to execute. Okay, is there any further question that you want to put on this stage? Okay, if not, no, sorry. Okay.
It doesn't show the star. That's
Oh,
suspicious.
okay. Well, probably, Yasmin, then if you are facing that kind of problem, you may probably try to close the tab or the tabs you may have open for this Jupyter Lab environment, and then restart everything again. So by using the link that we have shared before, the link for the Jupyter Lab environment.
Thank you.
Okay.
Okay, so I guess we can move on, and now we're going to talk about something a bit different. We're going to talk about pairing lists. So let me just. You know that when we have numbers, we can perform operations with them. We can sum numbers, you can multiply numbers, and you can do all of that. And there are also operations that we can do with lists. Okay, not exactly sum two lists or multiply two lists, but there are similar operations. And we are going to talk about one important operation or function, which is the zip function or zip operation. So you're probably familiar with the concept of a zipper, and you're probably wearing something with a zipper right now. The question is, what does this have to do with lists? Let's find out. So what does a zipper do? Basically, when we have a zipper, we have a list of teeth on the left side, here in red. So these are the left teeth. And then on the right, we have a list with green teeth. Okay? So we have a list of teeth on the left and a list of teeth on the right. Again, we are dealing with lists. We said lists were important. They really are. So we have two lists, and the zipper makes the teeth interlock with each other, pairing them. Okay? So when you push the zipper, the teeth will interlock with each other and it will close. Okay? So how can we actually apply this to lists, as an abstract operation, abstract and general operation? So suppose that we number the teeth on the left with 1, 2, 3, 4, 5, 6, and 7, and on the right with 10, 20, 30, 40, 50, 60, 70, and 80. Okay? So on the left we have the numbers from 1 to 8, and then on the right we have the corresponding number multiplied by 10. Then, for instance, number 1 will pair with number 10, and we'll get the pair 110. Number 2 will pair with 20. Number 3 will pair with 30. Number 4 will pair with 40. Number 5 will pair with 50. Number 6 will pair with 60, and so on. Okay? So we'll get the pair when tooth number 1 on the left pairs with tooth number 10. Okay, when we pull the zipper, we get the pair 110. And how do we write a pair? Now, instead of using square brackets, we use curved brackets. Okay? So this is not a list with the elements 110. It's another it's another type. It's a pair, an ordered pair. So instead of square brackets, we use curved or round brackets. Now, to see if you are understanding what we're talking about, Luis will now launch a poll, okay, and you should select the pair that will not be created by moving the zipper. So let me just share the whole screen for you to see something. I'm sharing my whole screen, okay? Now Luis will launch the poll, please. Your mic is turned off, by the way.
Yeah, just 1 second, because I really need to put polls here available. And so let me launch this one. Okay. Okay.
Okay, so you see here, you have the poll, but it's kind of blocking my screen. So we should close it. Okay, close it. And then come here, more. No, not more, here. Click here where it says
Yeah, poll.
polls.
Yeah.
And now the poll will appear on the right. And you can see both what I'm sharing and the poll. Okay, so you should close it and then click polls here to see it on the right, and then you should select, okay, the right answer and submit it. Okay, here, submit. So I'll switch back to my presentation.
Yeah.
Do we have answers yet? For some
Yep.
reason I cannot see.
Yeah. We already have answers.
Okay, yeah, so that's exactly it. So 222 will not appear because 2 will be paired with 20. So that's right. Everybody got it right. Yeah.
Sorry, Yasmin, can't you find the poll? You should click on the icon above that. You can see an icon called polls.
I'm gonna share my screen again. So here, polls, okay, you click on it.
If it does not
should
appear,
open here on the right.
and if it is not appearing like on the screen of Inês, you can click on those 3 dots and try to find the polls option.
Yeah, it should either appear here or somewhere here.
Not appearing. Strange. And Yasmin, after, did you were you trying to find it by clicking on the three dots? I don't want to see the poll. Well, let me check if I can launch it again. Yeah, we'll try to do slowly in the next poll, okay, for the activity 7. And we'll check with you if you were able to see the poll at that stage.
Yeah, so when the pairing is complete, we will have a list of pairs. Okay, 110, 220, 330, 440, and so on. So notice that we have a list on the left, 1, 2, 3, 4, 5, 6, 7, 8. And then we have a list on the right, 10, 20, 30, 40, 50, 60, 70, 80. And when we pair the lists, we get a list of pairs, not a list of numbers. Each element of the list is a pair, okay? And in Haskell, there is a built-in function called list that does precisely this. So it takes two lists as input and returns the corresponding list of pairs. However, to be easier more intuitive, we use this symbol to identify this operation, okay? So if we do like 1, 2, 3, and then we write this symbol and then 10, 20, 30, we are going to get 110, 220, and 330. Let me share my Jupyter. Okay, so you will, after the session, you will have access to this Jupyter Notebook too, but for now you won't. Otherwise, you see all the answers, and that's not fun. So you see we have here the list 1, 2, 3, and then I'm going to zip it or pair it with 10, 20, 30. And if I run this cell, I get 110, 220, and 330. All right? Cool. Now, let's do this activity. Suppose we have one list with some people names. So Anne, Ellen, Joe, Mary, and Paul. And suppose we have a second list with the type of clothing they are wearing. So Anne is wearing pants, Ellen is wearing pants, Joe is wearing pants, Mary is wearing a dress, and Paul is wearing pants. If we pair the first list with the second, we get a list of pairs. So now Luis will launch a poll, and you should select which of the following pairs appears on that list.
And please, Yasmin and Cesar, please just check if you can see the poll on the center of your screen now. No. I don't know if it then it can be are you using Teams on the browser? I think so, right? Because you probably have something okay. You probably have something that is blocking. Yeah. Yes, Cesar, that's right. Because I think that you may have something that is blocking the appearance of windows like this one. And so, yeah, that's something that you need to solve in your browser. Or if you want to try to a different browser, if you have it installed in your computer or something like that. But it's because of that, I'm sure.
Yeah. Computers. Sometimes they are a pain.
Oh, thank you, thank you.
Yeah, let's just wait a little.
Yeah. Okay, so
Can I reveal the answer?
okay, we already have 3 answers.
Yeah. So let's see. You may ignore this cell. So I'm going to zip or pair these two lists. Okay. So I'm going to click play and I get this. So Anne is wearing pants, Ellen pants, Joe pants, Mary dress, Paul pants. So the only pair that appears is Anne pants. That's the right answer. Okay? Now
So
suppose,
also for you to understand, every time we are talking now about this concept of this zip concept, we are again doing something that is related to the models that we may use in order to create the data and to deal with the data we intend to deal with. Okay, so every time we have a problem in which we have data separated in 2 parts, but that you can combine in somehow, and so to create pairs based on those elements, then we can use this zip operator to do that. Okay, so it's an operator, but at the same time it's creating a structure that will represent the data that we want to deal with. Okay.
yeah, it's really very useful. It's a way of, saying that the elements on the list on the left and the elements in the list on the right are somehow related. Okay, and the relation becomes very explicit when you pair them.
Yeah, and so we are pairing 2 models. Okay, so we have a model on the left, which is a
Two
list of
structures.
names. Yeah, and then you have a list on the right as well. So you have these 2 submodels, if you want, of these 2 parts of the data you want to deal with. And then with this operator, you are creating a new structure that will represent the data that you want then to explore, to transform, and so on. Okay.
Yeah, now suppose that we have a broken zipper on the right, for example. What happens in that case? On, like after the second teeth on the right, we cannot move the zipper more. So we will only form 2 pairs in this case. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then we zip it with 10, 20, and we only get 2 pairs. 1 is paired with 10, 2 is paired with 20, and then 3, 4, 5, 6, 7, and 8 cannot be paired because there are no more teeth on the right for them to be interlocked with. Does it make sense? Okay, so let's see if the computer agrees. You see, I can only pair 1 and 2 with 10 and 20. These cannot be paired because I have no more elements on the right. Okay? And what if one side only had one tooth? So for instance, I want to pair 1, 2, 3, 4, 5, 6, 7, 8, but on the right I only have one tooth, 10. What will happen? Well, I only get a pair with 1 and 10 because the other numbers cannot be paired. So I get 1, 10. It's intuitive, I think. Last, what if we have no number on the right, no teeth on the right? So if the zipper on the right has absolutely no teeth, then the slider can't do anything. Because if there are no teeth on one side, we can't push it above. So the result is going to be the empty list. And what is the empty list? Well, as the name indicated, is a list that has no elements. So if I perform this operation, what happened? Oh, I deleted the cell. If I perform this operation, I get the empty list. So this resembles multiplication by 0, right? Because if you take any number and you multiply it by 0, you always get 0. And if we zip a list with an empty list, we will always get an empty list.